screen, right?
Now, yes.
Yeah, okay. Okay, so yesterday we started with this transformation logics. So how to write a transformation logic in it. So it's more with the coding related, but we should know as per see, if you know coding, that's fine. If you don't know coding, then also fine, because like you can take an ABAPer help always. Like there would be ABAPers in the project, like we can take ABAPer's help in terms of writing a specific critical or complex logic. Then there won't be any issue in general, right? So we, in fact, like we also take ABAPer's help in required times, right? When we required a critical logic need to be implemented, right? Anyway, like we can understand the ABAP logic, but see what happens like from 7 onwards, like version 7 onwards, like it's become a OOBAP, object-oriented ABAP. So it's bit difficult to understand, kind of, at least for me, kind of. So it's so that's the reason, like when we end up with writing any complex logic, I can mention. See, even though if you consult any ABAPer, say, like, so this is my requirement, saying that I need this amount into quantity, so the price into quantity to get my amount, please write some code. So he don't know, right, what is the object and where he should go and how to start the coding and all. So all those things, like, we should direct him, right? So for that reason, we majorly concentrate on this transformation, like what are all the different structures we have and what are all the different places that we can write some code, and where if we write the code at one place, like what happens, that kind of information we should have in on hand, so that I know even ABAPer don't know anything, we just write the logic, right?
So, but any given time, our logic will be during the transformations time only. Is that right, Naveen?
Yeah.
Okay.
Yeah. So any point, any given time, yeah, logic would be during transformation, and as well as, like, we have multiple places to write logic. One more place is kind of a data source enhancement, as Aga yesterday said, like we got source system got 17 different tables to integrate. So if you have some logic to integrate all those things at a source side, so if all those fall in at least in a ERP system or SAP system, we'll write a function module at a source side itself and create a data source on top of that function module, right? There also we required a lot of other coding, and we, as I said, like SAP has tightly integrated with the BI system, SAP BI system. So what does it mean? Like to pull its sales data, its data, its finance or HR data, they have delivered lot of data sources, built-in data sources for us, for a BI point of view. So the data source, what I mean by data source, the data source contain lot of coding to pull the data from different tables to get a segregated, maybe a sales data or a finance data and so on, right? So they have delivered lot of data sources at a ECC point of view. Now, to use them directly into your BI system is one way, or else, like, they might require some or other customizations, right? So that point of view, we need to, that means, like, the customizations we called as enhancing the data source, right? So during the data source enhancements, we required some coding, and as well as coding required at the time of reporting as well. As I said, reporting are in three different phases. One is simple reporting, medium, or complex reporting. So till medium reporting, it would be only using the reporting objects. We will design a different types of reports. But when you talk about the complex reporting, that comes into a, when we introduce that coding into it, then it become a complex reporting. That means, like, we'll use variables, and to generate that variables, or to get the value for that variables, one of the method is through coding. So we can base out of some other logic or some other method, like we will write some code to populate a value for that particular variable. So based on that variable, your report will execute. So kind of. So there are multiple places and multiple scenarios, but data manipulation. So data, whatever the data source, the logic we write in a data source is to pull the data only for extraction related. And once data enter into the BI system, so but the data manipulation within a BI system is where, like in a transformation logic, right? So data manipulation means the transforming section, like all the business logic application, applying the business logics, everything in a transformation phase, right? So to apply the logic in a multiple way, one is kind of a full record level or another kind of a field level. So record level, we have two different routines, in fact 3 different routines, like a start routine, end routine, and one more routine we have called a expert routine, right? So it will lay there, lying here. See here, this is an expert routine.
Oh, okay.
Right. So okay, so what happens, like when you create a start routine and an end routine, it become a row level, the entire row level your code. And if you write a logic at a start field level, so that become a field routine. So we will see the field routine first, and then we will go for a row level. So as we are describing, so we have different types of field level routines, that are rule types. So one is constant, that you mean by you can give a constant value for a respective data type and target, right? And then direct assignment means like whatever the source we have, like the same source, the source value, the same value will be passed to the target field value, right? And then formula. So as we seen yesterday, so formula, okay, we have seen at a data source here. Right, so this is a formula. So when you select a formula, right, you will get a screen like this. What all the inputs you have, that inputs you will get it, and then you will have different system variables we have, like a date and time, and we can give a database user and the user ID and so on, operating system details. So oddly we use only this current side item, right? And then we have a lot of functions, like a basic function, mathematical functions, and so on, right? Characteristic functions, date functions, right? So we do have a lot of functions. Like by using all these functions, we can derive our own formula, right? So once we define our formula here, like, so it's matter of, right, adding different one or other different formulas only, right? So just clicking something and so on. If you want delete, you can go and delete sign. So we normally don't type it anything here. So but still, like, if you want type, you can go and type, but it's not that much useful in general, right? And now, and once you confirm, like whatever, even it is a constant or anything, once you confirm like your logic is done, you need to say here one more step as a transfer values. So if you don't transfer anything, you won't get anything assigned there, right? So for example, so I will give some constant here. So okay, I will assign some constant. So I am not saying any transfer value, so I will just say okay. Other than that, I don't have any other option itself, so to say okay. Check is fine, right? When I say it doesn't say anything. So we have to go for a transfer value whenever we, after completion of our logic, whatever, even constant or formula or even read master data, anything, then we have to go for a the transfer values, right? So, and then read master data. The next one after formula, we have a read master data. So whenever we fall in a situation like this, so I have so my target field, right, my material type, I'm not getting directly from my source. Like the source here, it is a data DSO, standard DSO. In a standard DSO, I'm not having material type, but in my cube, I'm expecting material type. So obviously question like from where I can get my material type. But as part of my material attributes, I have material type, right? So I can take this material into here in a material type, assign this to a material type, and say get the value of material type by checking the master data of your material, right? So that is what it means. So read master data. Yeah.
Is it material or material type master data?
Read master data from attribute of this material. So materials attribute is material type. So we are informing the system saying that to have this material type in my target system cube, right? Read master data from attributes of my material. So my material type is one of the attributes. So get the data from there. That is what it means. So it internally it checks for check in its respective P table, right? So and then it will bring the data.
Oh, okay. Just because in material table, one of the field is material type.
Correct.
So that it can go read indirectly and bring it from there. Okay.
Correct. Yeah. Yeah. So that is read master data, and then we have routine, right? So individual to define this particular field, we can write some routine, right? We may have some logic saying that here I don't find a material here, for example, or else so this whatever here material type that read master data will be with respect to the technical name should match, right? Technical name should match, then only you will get the master data. If my technical name is not matching, then I have to get the material detail from this material P table, right? So then I have to write the logic there. So go for a routine. So when you go for a routine, right, it will take you to this screen where you can write some logic, right? There might be a lot of coding align here, but still we have to go for a place, so it will directly take you to the same place. So this is our initial screen, right? Whenever we go for a routine, this would be my initial position. So here it says begin of routine. So left, leave everything like whatever we have in that place, but just go for a begin of your routine, insert your code here, right? So this is the place where you need to write your code, right? So till here, so till from this begin of routine and this end of routine, between these two we have to write our code, right? So these are all the whatever the matter we have here is all kind of a comments, so we can ignore all of them as of now. So we can write our logic here. So for example, like so as this is the field level routine, right? As this is the field level routine, so once the complete logic, for example, you are performing a okay, so I'm just going for a read master data, that's fine, transfer value. For example, here in a logic section, so instead of going a formula, so I'll write a logic here, right? I'll go for a routine. So I have some complex formula with this and that. My formula is not able to maintain. So right here. So now after applying all your logic, the final resultant value I should pass to this result object. Then only your value will be passed to your respective field, right? On this field we are trying to, on this field to populate value for this field we are trying to write some logic, right? So when you pass the value, the final resultant value to this result field, then only you will get the value for that particular respective amount field. So why, like if you know ABAP, like I can explain bit like, so here within a lot of ABAP code, what happened, so there is a method it's calling, saying that, like, for this method, these two are input fields, like material. So if you closely observe, this is the material price, right? And this is the material price, and this is my material quantity. And exporting, so importing means like the function imports these values, take these values, and exporting means function will return these values, right? So the result, so finally it's what is saying, the amount type of object, that is the result, it is giving an output. So that value we need to populate here. So whatever the logic what we need to write, so maybe here itself we can write some logic. So it's like this. So we need to always concatenate this source underscore field hyphen the field name. Okay, then star. So this is what our logic. So I'm just writing. So this, or else like we can declare a variable and we can assign this calculation to that variable, and that variable x can be assigned to the result. Either it anyway, the same thing, right? So we can write some logic like this. The final result must be go for this result variable. Okay, so then we can go for a save and go for a transfer. So either way are same, like write a logic or write a routine or write a formula based out of our requirement. Like if your formula is too much complex that you cannot handle, or else like your formula is based out of lot of conditions, saying that if my price is my quantity is greater than 100, then my price is less, or my quantity is less than 10, then my price is bit high. So based on conditional based logics are there, kind of things, then we will go for a routine here, right? So the routine we can write. So when you go for a routine, like it will take you to the position where you can write your code. So you can ignore like whatever the code or whatever the comments that, no, these are all, even in fact, like these are all kind of a disable mode. So there won't be any enablement. Only this place will be enabled where you're supposed to write your code, right? So the code will be kind of we using an ABAP language. So it's like this. So once you write, so this is the place is again a check. So it will check for a syntax. Then we can go for a save and then say transfer values. So it will have this symbol, right? So likewise we have different field level routines, right? Any questions so far? Or?
No.
Yeah, you're fine. You're good, right? Okay.
Yes.
Okay. So likewise, like we can go for a different type of field level routines. So, and one more routine we have, no transformation, is I don't want to populate the value for this at this point of time, and here the no transformation will come only the non-key columns. For key columns there won't be any no transformation, but it would be kind of initial, right? Initial value. So because like key columns is, it cannot be null, so there won't be any kind of a null value need to be populated, right? So likewise we can write our respective individual field routines, right? Okay, so then comes to a start routine and end routine. As I said earlier, it is both are record level routines, right? it try to manipulate entire record. But what is the difference between start and end routine? Start routine will be with a group of the source records, right? Whenever you say start routine, it will take the data of whatever available at the source records, like with the source structure. So it will have this source structure. So based out of this source records, we can apply our logic, and then finally it will ready for push the data into your transformation level. And then end routine will always, after your individual field routine applied, like you will find certain set of records, right? So that records will be manipulated in an end routine. So start routine will be manipulated the source records which are before applying the individual field routine. This before applying the transformation logics, right? These individual field level transformation logics, the start routine will apply, and then individual field routines will get applied, and then end routine will get applied, right? So it's like this. So the cursor means, like when you say execute DTP, right? In a DTP, when you say execute, right, it will pull the records from the source and try to apply it. If at all we have, then try to apply the start routine on those records, and then apply all the individual field level routines, right, for all the records, and then finally go for an end routine, right, and then then it will pass the data into the target system. So pull the data. Yeah, yeah.
I have a question. Yesterday, if I understood correctly, whatever you are going to write routines on the source table, source records, that will be start routine.
Yeah.
Whatever logic you are going to apply on the target, the right side records, that would be end routine.
Your voice was.
So what I was saying is, for end routine, the logic which will be applied on the target level, target record level, that will be end routine.
Yeah. So yeah.
Is that right assumption, Naval?
Yes. So it's like this, right? So whenever you have some you have source, right? You have source. So these data need to be passed to a target, right? So what happens between these two? So first, the source records will be fetched into some temporary structure, right? So that structure, TV underscore, SC underscore, S underscore, I forgot it. Oh, so there is a structure, TY underscore. It starts from TY underscore, SC underscore, S underscore 1, I think. Yeah. So source structure, this is a structure name.
Okay.
Right? So it will take you into a structure. So all the data, whatever we have here, will move to this structure. Right? And then once the data arrive in the structure, then all your start routine will apply on this particular structure. What happened?
Okay.
Okay. Start routine will apply on this structure. So once this start routine applied, the final resultant of this structure will move to individual field routine level. Right? The final. So once apply the start routine, the final resultant set of this structure, right, will move to a basically it will have a table. So this table. Right? So it will move to this data will get applied for all the individual field routines. So every field routine, every field level routine, we will be having a method as we seen just now, right? Method 1. Even it is for a direct assignment or even it is for any kind of a assignment, we will have an individual level of methods, right? So all these methods. So maybe we have 10 fields. Right? So it will apply it will pull the record each and every. Suppose we have 10 records, right? So pull one record and apply all this 10 and push it into the target structure. And before we data move into the final target, we will have again a target structure. TY underscore TG underscore S underscore 1, and the table would be TY underscore TG underscore T underscore 1. Right, so these are all constant names, like constant structures and constant names, irrespective of your source and target. When you have a transformation, they're all the structures, right? So it will be like this. So first, and then it will go here. Then finally, it will get it. So it's like this. So it will pull the data from the source and push it into the structure, right? Right. It's a bunch, and then finally start routine, and between these two it would be end routine, right? So, and once your start routine completes, so we have a set of records after start routine that with the source structure in the source table level. Now one after the other, it will pull the record and then apply all the field level routines and push it into the target structure. Once all the records arrived in a target structure, right, you will get that end routine get applied, and then final resultant will be pushed into the target. Right now, as part of my start routine, my records may get increase or decrease. Anything may happen, because like this start routine would be kind of a record level, right? Record level. So when I have some record level calculations, for example, I said deletion. We can go for a deletion. So I don't want all the data whatever coming from the source need to be pushed to the target. Only the data which is company code is US. Right, I don't want Canada related records to process this entire target, right? So I can delete them, right? So likewise, we can go for any kind of record level manipulations, or like if I am getting data from maybe Canada and US, then I need to split those records into multiple records. I can do it here in logic itself. So likewise, we can go for any kind of record manipulations using your transformation logic. So this is again where your ABAPer will apply his different methods, like it will use they will use our internal table concept and work area concept. That is like in a PL, if you know PL SQL, it would be kind of cursors and so on. Right.
Okay. Is it like same thing like open cursors and fetch the
correct.
Okay.
Yeah, so but in ABAP it would be kind of an internal table and work area, that concept. So they will apply all those concepts and within this start routine. So ABAPer don't know about this structure, like what is the structure, what is the table, and what is this, how the data flows and all. We need to take them into this start routine level and ask them to write some code using the respective fields, right? Then only they will apply some code. That's it. They cannot understand like how this trigger flows and everything. So here and here, these are the only places where ABAPer can write some code, but the rest of the logic and the cursor flow and everything we should take care, right? In general. So you understood this logic and data flow, right? So how this structure will flow and how this individual and this flow, right? And a theoretical.
Yes.
Okay. Now if you go to start routine, right? So forget about the rest of the disabled part. Go for a begin of your routine. Insert your code here, right? So here, as I said, the structure name ty underscore s underscore sa underscore 1. This is a source structure. Okay. So this is a standard source structure for all the transformations, not only for only this, or only not respect to any kind of a source or any kind of a target. For all the source structures, this is the standard structure name. Even in interviews, people will ask like, what? So if you're, they will ask like, are you okay to write your code by your own? Maybe like you know the structure or a flow, right? Then if you say, okay, yeah, I know the structure and all, so could you name what is the source or start routine structure, right? Name of the, because this is a standard structure, ty_s_sc_1, right?